Nikhil, shall we start?
Yes, sir. Start.
Okay. Uh, can you change? So,
Yes, sir.
okay, okay. 1 minute. Good evening once again.
Good.
Uh, uh, now, the sixth session will be starting. On behalf of Maharshi Karve Stri Shikshan Sanstha and Cummins College of Engineering for Nagpur, I welcome Dr. Vijay Didolkar, sir, to this AICTE sponsored ATAL FDP on 21st century materials advancement in science and technology. Dear participants, we all are a faculty and we know that since the implementation of National Education Policy 2020, we have, introduced to Indian knowledge system into our curriculum, and we know that. And ancient Indian science is one of the topic comes under IKS, Indian knowledge system. We have, in India, we have many people who have actually worked on the old scriptures and developed some contemporary technology, techniques, model related to the subject based on the Indian scriptures. So in line with this and related to the material, today we have with us one such a personality, Dr. Vijay Didolkar, who has actually worked on some of the Indian scriptures, and he has drawn the knowledge and he developed some techniques uh, uh, related to material process. So Dr. Vijay Didolkar is a professor retired from VNIT Nagpur. Uh, he he was teaching in the material department in the VNIT. More than 30 years of teaching and research experience he has in mineral processing, in coal, graphite ores, clays, iron ore, etc. He has visited many countries like US, UK for the lecture series on ancient Indian technologies and Delhi Iron Pillar. Uh, Sir has developed IR glass as per Indian text Anshu Bodhini, and he was awarded for this work from Karnataka Sanskrit Research Academy for that. He has also developed ancient iron making technique. Uh, Sir was a TCT fellow for of British Council in 1997 as well. So uh, I welcome Dr. Vijay Didolkar sir for this faculty development program, and I now, without wasting a time, I request you please start your session. Thank you.
Thank you, sir.
Thank you. Nikhil, please.
I was actually professor of metallurgy and materials engineering at VNIT Nagpur for more than 35 years. As the original text in Sanskrit, that is Brihad Viman Shastra by Maharshi Bharadwaj. Part of that is one of the chapter is Anshu Bodhini, and in that we see some Sanskrit standards which are related to special type of glass, and subsequently taking the help of since we don't have sufficient Sanskrit knowledge, we took the help of, at that time, I was actually secretary of Vigyan Bharati, for that is All India Secretary, and I know different personalities doing researches in the area of materials engineering as well as other fields. So one of the unit at Varanasi we contacted, and they have Professor Dongre, who is professor of physics at Kashi, and the whole text, those few stanzas were actually given to Professor Dongre, and he has actually decoded the entire material in literary English, our common English. And as per that, the material was actually, as per the heading, a novel infrared transparent glass material as per Anshu Bodhini. So this is also in Sanskrit, it is called as Prakasha Stambhanabhid Loha of Maharshi Bharadwaj, which is described in Anshu Bodhini, that is chapter of Maharshi, your Bharadwaj Brihad Vimana Shastra, and the original text is in Sanskrit and was decoded by Dr. N.G. Dongre, who was actually a very good friend of mine. So, next one. Now, material with, now they have described this Prakasha Stambhana with Loha. One of the material is Khachara Loha. I think Kha is the word or letter used for Akasha. So basically, it is as per his knowledge, he described this Khachara Loha as silica 100%. So we took silica, then second raw material in 8 parts, which is described in the original text. So Khachara Loha, 8 parts, Bhuchakra Suramitra Dikshar. Now this is again a very typical material. Bhu Chakra Suramitra. Suramitra means, Sura means God. Sura उनका मित्र यानी Suramitra, and the material is obtained from this Suramitra, and it is the calcination that is carried out to give you a kshara. Ultimately, we found that this material is calcium oxide. Then third is Ayaskanta, Fe3O4 lodestone, which is very commonly used even nowadays. Fe3O4, that is 4 parts. Ruruka, that is deer bone ash. Now this is a typical material we took. For that we went to our local Maharaj Bagh to search the hiran, harin jisko bolte hain, that we search out, and deer bone ash. But again, it is in the original text It is the young deerbone ash, that is growing deerbone. A deer should be there. And that is actually 6 parts. Basically, it is the calcium, that tricalcium phosphate. So all these 4 raw materials were their uh, corresponding molecular weight, and all these things were calculated. And as per the original text, they have described this parts by parts. So that was their earlier style. So 8 parts SiO2, around 37%, 5 parts CaO, calcium oxide, that is 21.5%, Ayaskanth, Fe3O4, 4 parts, that is around 17.7%, and lastly, Ruruka, that is young deerbone ash, calcium, tricalcium phosphate, around 23.8%. So accordingly, the percentage from parts, we calculate the percentage taking into consideration the molecular weight. And like this, basically the empirical formula for the final product as per the above table is 5 in bracket CaO SiO2 calcium silicate. Then second bracket Fe3O4, and then Ca3PO4 twice, that is calcium, tricalcium phosphate. So it is basically a lime glass containing dissolved coloring agent as ferropheric silicates and forming a clear emulsion with tricalcium phosphate. Thus, Prakash Stambhana with Loha contains silica, lime, lodestone, and phosphate in proportions of 37, 21.5, 17.7, and 23.8 respectively. The second important thing is the use of rotating crucible. In the original text, they mentioned Brahmanika Musha, that is crucible which is rotating continuously. Now, such facility was even not available at VNIT. So, instead of rotating crucible, we took the crucible in which the liquid is there and which is continuously stirred. Use of a third point, use of a lodestone as coloring agent instead of iron oxide ores. So this lodestone is actually the stablest oxide of iron, and it will not be, even in case of iron pillar, the final outermost layer on the iron pillar is also of that of Fe3O4 or lodestone. Fourth important consideration is weight of mushti. Yes, that is, which is around 54.24 grams. So manufacturer's mushti is, so like this, there are so many assumptions. as per Vedic numerical code, the temperature was mentioned in Kaksha. Now, this Kaksha is around 3.54 degrees Celsius. One Kaksha is, the scale was actually provided in the Vedic text. One Kaksha is 3.54. 101 Kaksha is boiling point of mercury, 357. 6 Kaksha, 21.24, also called as one. There are very large number of such calculations shown in the, for these actually the melting point of gold. So we took around, in the original text, all these raw materials were heated to 940 degrees Celsius, which is, it is slightly more than that. In actual practice, we found that this melting point or fusion point, this is actually the original Sanskrit text. पश्चात् स्तंभनाभिद लोहेषु खचराख्य लोहस्य अष्टभागांशकम् तथा भूचक्र सुरमित्रादि क्षार पंचकम् अयस्कान्तस्य चत्वारि च रूरुकस्य षड्भागः एतान् तत् भागानुसारतः विधिवत् सम्मेल्य पश्चात् ब्राह्मणिका मूषा मुखमध्ये प्रपूर्य पंचषष्ट्य षष्ट्युत्तर द्विशत कक्षोष्ण प्रमाणतः गालयित्वा. And the third shloka was yantrasya ativegen prapurayet tada prakashastambana vidloha etat kritakaloha bhavet. That is, by this they have described the how to prepare this material, prakashastambana vidloha, and the process of manufacturing. Actually, you will find Brahmanika Musha is required. All these raw materials, that is calcium oxide, silica, then Ruruka and Ayaskanta, all these raw materials, they are of a particular size. And again, one important thing is yantrasya ativegena prapurayet. That is, this clear liquid which is obtained in the crucible is to be poured into the mold. Ativegena means very swiftly, without wasting any time. Then only you will find all the unwanted stresses and strains developed in the glasses. They are completely removed. Now we first consider 4 constituent raw materials. Khachara loha. Khachara means traveler in space. Kha is generally the vowel used for Akasha. Prominent star in Akasha is sun. And related material as per Indian mythology is Spatika or quartz. They are having similar compositions, or silica or SiO2. So that is how the our professor Dongre developed or decoded this Khachara loha as SiO2. Second raw material is Bhuchakra Mitradi Kshar. Now, Bhuchakra materials composed of earth which spiral over the surface. Suramitra means Vishnu, and thus the material is what we are doing in our puja. Daily puja is, they call it as shaligram. Now, this shaligram, black colored stone, that is actually the Suramitra Panchavarga Dikshar. No, only not that. This is nothing but the kshar or calcination. Its calcination is carried out. So that is CaCO3, calcium carbonate, and we calcinate that particular material to give you CaCO3, giving you CaO plus CO2. So thus the whole entire Bhuchakra Suramitra Panchavargadi Kshar is nothing but calcium oxide. Third is Ayaskanta, material which attracts iron. Also, earlierly, our Fe3O4 is magnetite, is also called as Ayaskanta in olden days. So this is simple iron or Fe3O4. And the last one is Ruruka. Ruru means young deer, and so material is deer bone ash, uh, which is nothing but phosphate of calcium Ca3P2O8, calcium tricalcium phosphate. Might well, all these materials we found that they are added to this particular production of Prakasha Stambhana with Loha to give you typical properties. So, 8 parts Khachara Loha, silica, SiO2, 5 parts, 21.5%, Bhuchakra Suramitradi Kshar, lime, CaO, 4 parts, 17.7% of Ayaskanta magnetite Fe3O4, and 6 parts, 23.8 of Ruruka deerbone ash Ca3P2O8. So all these materials are mixed in the proportions given. And important thing is again to have a very good fusion, because all these materials are of different categories. Young deerbone ash and the kshar obtained is again even Ruruka. They are entirely different materials. So they take very long time to fuse. So generally it was observed that all these raw materials, they should be less than 100 micron size. Then only you will find very fine powder. 100 microns means 150 mesh BSS. So that is the size required of each of these different raw materials. And then these are taken, all these, they are very properly mixed. Mind well, mixing is also very, very important. And then they are taking the help of suitable blenders and mixers. We mix them together and all having sizes less than 100 microns, and they are melted in a, we took the, instead of rotating crucible, we took the simple graphite crucible. And that is Some arrangement was actually provided to this crucible in the furnace, so that as soon as the material is completely fused, and you will get a clear, clean liquid in the crucible, there is some arrangement from the top, so that the entire molten mass is completely stirred. The temperature used was around 940 degrees Celsius, but the molten metal liquid product is rapidly poured into yantra die mold. In this way, the Prakasha Stambhana with Loha was actually prepared. The first trial was actually carried out at VNIT, our lab, and we found all these raw materials are in their suitable proportions were taken, and they are put in a suitable graphite crucible, and the crucible was actually put in inside the muffle furnace, maintained at 940. You cannot believe actually that particular first trial was completely failed. All the entire few kilometer area of VNIT was completely having a foul smell. Like वो स्मशान में जैसे ये आता है स्मेल, same was there in the entire campus. And everybody was complaining to metallurgy that what type of experiments you are carrying out. So ultimately, we have to stop the first trial because of this particular foul smell. And after that, I took the decision to carry out the whole fusion or melting in open atmosphere. Because the smell was always there, and basically due to the young deerbone ash. So the decision was taken to carry out this experiment in a simple coal-fired furnace. Now, such furnace was actually prepared by our team at Dhantoli area, and even this it was a very open space of around 100 by 100 meters. So that space was actually utilized, and in the center we put a the furnace, also actually called as pit furnace. So that pit furnace, over which suitable it is a simple brick and मिट्टी का वगैरह ये सब यूज करके and some few pieces of refractory bricks, especially to avoid the heat losses. And that was again, we slightly improved the size and shape and type of raw materials. Because in the earlier first experiment, we found, which is carried out at VNIT, it was observed that the fusion was very, very slow even at 940 degrees Celsius. And it will take a very long time. So instead of or cutting short the duration of heat, we took the raw materials with instead of using calcium oxide and silica separately, we took the glass beads, calcium silicate glass beads, those fine nodules which are subsequently ground to 100 micron size in 13 parts. 8 parts of your khachara and 5 parts of your calcium oxide. So like this, these two are combined 13 parts. 4 parts again Fe3O4 and that is 18 grams. First glass bead powder was 58 grams. And the third material, which was earlierly young deerbone ash, we use orthophosphoric acid instead of young deerbone ash, around 6 parts, which is 23.8 or 24 grams. So 58 grams glass bead powder, lodestone 18 grams, and orthophosphoric acid 24 grams. So such a mixture, again the size was less than 100 microns. Now this trial was actually found successful in the pit furnace, which is say coal-fired furnace. Using coal as a fuel, we carry out the entire heating, and within a span of say about 3 hours continuous heating at 940 to 950, we found the entire material, solid material, is converted or is actually fused, and subsequently you are getting a clear liquid which is having a color slightly bluish, greenish, yellowish, something like that. Such liquid is found to be obtained in the crucible, and that clear liquid is poured instantaneously into a preheated fire clay refractory mold. Now, fire clay mold is already prepared, which is preheated to a temperature of around 500 to 550 degrees Celsius. Now, this mold is of size which is governed by the testing facilities. And this mold was ready, and in that mold, we poured this clean liquid obtained in the crucible at a very, very slow rate to a room temperature. Now, the cooling should be very, very slow, though the pouring process should be very, very fast, but the uh, cooling should be very, very slow to normal room temperature. Now, as per the sample was finally prepared, this glass material will be produced on the larger scale. It is important to note that most of the currently used infrared glass filters for the manufacture of prisms, filters for the cell, etc., are highly hygroscopic in nature. And This particular material which is produced as per the Anshubodhini is found to be completely non-hygroscopic. It will not absorb any type of moisture in the structure for a reasonably good average life. And also life, there are various types of IR glass filters, but this was actually a very, very cheap. Cost wise, you will find the cost of these filters is 10 times higher than our Anshubodhini filter glass. And again, important thing is it has a very, very long average life. In almost all the IR glass filters, we found that after, say, the average life is not more than 6 months to 1 year. After that, you have to, that property is completely lost of filtration, and you will find they are useless. But this particular Anshubodhini glass is found to be having a very, very long average life. Now, this is the this particular graph, the first one, will clearly indicating that the structure of this material is completely non-crystalline or amorphous. So it is a glassy type of structure. The second graph you can see giving you glass transition temperature, which is, and it is actually the glass transition temperature TG of this sample is found to be 400.34 degrees Celsius. Also, you can also see that it is completely non-hygroscopic. The wet loss is only 0.009, which is more or less negligible. So it can be called as completely non-hygroscopic material. FTIR of the sample transmittance of nearly 7% at 5,000 per centimeter. And as you can see this particular graph, it is only transparent for this particular 2 to 4 micron wavelength. Since it is 2 to 2 microns steadily rises to 24% at 2,500 centimeters inwards, that is around 4 microns, and finally drops very sharply to 3% at 2,200 centimeter inwards and remains steady to 1,200 centimeter inwards. So 8.3. So in this particular range, you will find the the band of radiation of infrared is only transmitted. All other radiations other than this particular band, they are completely opaque to this particular glass. Density, regarding density, are all these important physical properties. Density of air glass is found to be 6.791 grams per cc by carried out by displacement method. Color of the grass is greenish, brownish, yellow. Now the now this is actually the graph Prakasha Stambhana with lower wave number centimeter inverse you will see on the x-axis and percentage transmittance. So this is actually the range in which the band in which the material is transparent. Now, to the surprise, in space, we are having very large number of such different types of radiations and which are not suitable for human beings. So this particular range is found to be the most beneficial to human beings. All other radiations, they are having very bad effects on the human beings. So this Prakasha Stambhana with low is only transmitting those radiations from the entire radiation band, only which are say suitable or beneficial for the human beings. So I think that is in brief. Now using this particular infrared filter glass and Brahad Viman Shastra, our colleague Dr. N.G. Dongre of Kashi prepared a spectrometer which was called as Dhvanta Pramapaka Yantra and published the paper on this topic in Indian Journal of History of Science, 1998. From the same book, Professor Ramchandra Rao, Director NML, Jamshedpur, has prepared a glass Prakash Stambhana with loha and which is found to be having similar type of properties. But we actually modify the original raw materials into different chemical reagents like tricalcium phosphate, then Ayaskanta Fe3O4. Though Fe3O4 Ayaskanta is not readily available in the market, we give a suitable magnetizing roasting treatment to hematite and 100% complete conversion of hematite to Fe3O4 magnetite was carried out and was tested. And this material was actually used as Ayaskanta. Now this small picture, Dvanta Pramapaka Yantra. Now this is developed by our senior colleague, Dr. N.G. Dongre. Now at the base, you will find there is a circular scale and over which there are 1, 2, 3, 4, 5, 6 filters and each disc these are actually disc and you will find one dot there. That is actually the different material. So 7 such different filters are used. So radiation is passing through all such type of different filters and finally you are getting a circular spectroscope And this spectroscope will directly give you the frequency of radiation. There is no other simple equipment giving you directly the radiation frequency simply by 1 unit. So there is a circle spectra. Now this Dvanta Pramapak Yantra Bharadwaj was prepared by basically Dr. Dongre. We helped him, and the instrument was actually after his demises, the whole Dvanta Pramapaka Yantra was actually transferred to Pune, Bhandarkar Research Institute, and it is available there. If you want to observe, you will find it is available. And since the Bhandarkar Research Institute is going to be having its centenary celebration on 11th January 25, there is a very good function there, and at that time you can see this particular Dvanta Pramapaka Yantra of Bharadwaj. So I think that is all about this particular material. Also, we prepared this is only used as a window glass material in ancient aeronautics, but the materials that is a what do you call it as general purpose constructional material for aeroplanes, that was Vataharnakhya Loha. Now this material was also prepared in the lab on lab scale, 100 gram or 200 gram level, and was actually this IR glass as well as the that is Prakasha Stambhana with Loha and Vataharanakhya Loha. Both these materials, when the samples were provided to as per their requirement, the DRDO ordered these two samples of 100 grams each to their lab at Hyderabad. So as per that, we sent these two samples. Also, after say, they found it very, very interesting from the viewpoint of construction of aeroplanes. And we found that these materials should be actually prepared in large scales. And for that, we went there, a team of experts went there at DRDO Hyderabad, where Dr. Saxena was actually the director of DRDO at the time. And we went there, and he has provided a complete laboratory setup for this material. And we carry out the materials, your raw materials production, raw material processing, and final product. All these are available there in their lab, and they are studying it very, very carefully. And last month, Dr. Saxena was available at VNIT Nagpur. He has come for some conferences, and he called me and told me that these two materials will be useful for us. And accordingly, we will carry out the further processing, that is all these patents and various types of academic work, royalty and other things at DRDO, Hyderabad in next month. So that is the typical scenario in case of ancient Indian technologies, in case of aeronautical engineering. To the surprise, since my post-graduation was carried out in 1976 at Indian Institute of Science, Bangalore. And at that time, Professor Kalam, Abdul Kalam, then our director of ISRO, and director of
Saraswat, sir.
IISc Bangalore. Huh?
VK Saraswat?
No,
No.
not VK Saraswat. Punjabi fellow.
Mhm.
His name is there in given to one of the halls there at IISc. Oh, I forgot the name. But we were very good friends. We took, say, around 4 to 5 rounds to the entire campus of IISc Bangalore. And he was basically aeronautical engineer. And Professor Abdul Kalam was actually visiting professor. At that time, he was actually not president or even advisor to science and technology, but he is regularly visiting by his own helicopter to IISc Bangalore. One lab was completely allotted to him for carrying out different types of, and that was actually the starting point. And to the surprise again, the name of our first satellite was actually discussed in our committee at IISc Bangalore, a students committee, and it was suggested that this particular satellite which we are going to send should be given the name Aryabhatta. So that was because earlierly we have visited, our director has taken a team of, say, about 25 to 30 students at the campus of Sriharikota, and where the satellite was placed. And we, at that time, the meeting was held again after seeing that particular satellite. We found that this should be given the first Indian name, that is Aryabhatta. And that was accepted by the entire team of not only ISRO, but even at IISc Bangalore. So again, with respect to iron making, again, I found some references in Rigved Mandal 9, wherein a special type of iron which could not be corroded even after a very long gap. The iron material will not be corroded. So that particular procedure was actually given in Rigved Mandal 9. And accordingly, we carry out some experimentation at my residence at Shivajinagar, Nagpur area, and the whole furnace was actually built up as per taking the help of nomadic tribes from Bihar. At that time, this technology was available only to nomadic tribes in Vishnupur area near Patna. And those were called here in Nagpur. And I think around 1996, and the whole procedure was carried out at the center. And they prepared a क्या बोलते हैं उसको? शिव जी का वो त्रिशूल त्रिशूल बनाया उन्होंने, and that was having a appearance like a your stainless steel utensils obtained from the naturally occurring hematite ore Fe2O3, and that is still there as it is without any corrosion, not even a single say uh, spot was there. So as bright as stainless steel. So that type of technique was actually known to those nomadic tribes, and we carried out. And on that, I have written a book also, The Iron Pillar and A Restless Wonder. That was the title. And which was, for that, I was actually invited to various universities in US, that is New York, New Jersey, and Washington, D.C. Also, some of the universities in UK, where I have given a series of lectures on this particular topic of uh, Delhi Iron Pillar, a restless wonder. So, like this, the entire ancient technologies for the last 15 to 20 years, I am actually completely, even today also, we are carrying out different types of experiments to develop some newer and newer materials from the ancient text. Thank you.
Uh, Thank you, sir, for a wonderful lecture. The topic is, I mean, something beyond imagination. I have a two question related to this.
Right,
The other participants as well, they have a question. Okay, I will let the other participant to ask a question, then I'll ask me.
right.
Okay, so participants, the forum is open for any question answer. Uh, Please feel free to ask the question. You please unmute yourself. Okay, I will ask you one question, sir. I have
Right.
actually two questions. Uh, since the topic of the program is related to advanced materials, my question is, what is the relevance of these ancient techniques with today's need of advanced material? And second is, how we can draw inspiration to develop a new material to cater the needs of new materials in various applications.
Now, as I already said, Dr. Saxena, Director, DRDO, Hyderabad, he was actually interested in such type of, and I have published a paper in some science congress at Kalina University, Mumbai, in 2015. And after seeing that, and the material was also exhibited there. After seeing that, he has written me a letter in which he told me that you should actually give us the procedure and how to prepare this material. Mind well, my professor at IIC Bangalore, he was also doing the similar type of research work in the higher class as per Amshubodhini. But uh, some intricacies in the procedure or process of manufacturing, you will find he was not able to be successful in this particular venture. I am the only professor successful in producing such type of materials. And for that, Academy of Sanskrit Research, ASR Mayakote in Karnataka, we were actually called there. Say about 36 different scientists who actually prepared some materials from ancient Vimana Shastra. They were called by symbiosis the around 2006. So we 36 together, and every one session for each material, and one or two scientists, those were provided, and the entire program carried out for say more than 8 to 10 sessions. So like this, that was, and the entire arrangement was made by Symbiosis Pune. And we were completely cut off from the other world. We will find that not even a single newspaper, TV, or news at least, they are not available to us for at least 3 to 4 days. So that was the first type of reward, you can say. Professor C.S.R. Prabhu, our Bala Sudhakar Shastri of ABS Shastri from Hyderabad, MP Rao, the Secretary of Aeronautical Society of India, Bangalore. All these different persons or different scientists were called there at Melkote. And I forgot the name, I remember. It is Satish Dhawan. Satish Dhawan was actually the head of IIC, director IIC Bangalore, as well as director of ISRO. So we are having a very good friendship with Satish Dhawan. And he was a very, क्या बोलते हैं, हंसता खेलता आदमी था एकदम. A very passionate person, loving. तो उनके, to be surprised, I was studying there in Raman Astrological Institute, and to have some knowledge at least of the astrology and astronomy. So, and as per the director of this Raman, he told me that there is no person or expertise available in the area of yogic kriyas. I told him that we are having a very good person from Nagpur who is available and having expertise in the area of yogic kriyas. You might be knowing Janardhan, Pujaniya Janardhan Swamiji from this Ramnagar area of Nagpur. He was very famous especially for this yogic kriyas. And for this, uh, I have actually having a very good relation with Janardhan Swamiji. So we took him to Bangalore, my hostel room, for more than 1 month. He was preparing his own food there. And right from the, say, 5:30 in the morning, he is continuously busy with teaching of all these yogic kriyas, neti, dhoti, basti, all these kriyas were actually uh, he is teaching. And one fine day, because always there is a huge rush surrounding my room, so somebody may have been complained, and director has given a surprise visit to my room, and he found that something is there inside. He directly went inside my room. I was outside taking some uh, uh, nearby friend, I think. In his room, I was actually doing some other work. After seeing that, I found that director is inside my room. So I went there and he told me, wait there outside. And he has a complete Sashtang Namaskar to our Swamiji. After finishing his discussion with Swamiji, he came outside. That is Satish Dhawan. And he came out and gave me a, a typical remark. आप लोग समझते नहीं हैं, इतने बड़े स्वामी जी आईआईएससी में आए और डायरेक्टर को पता ही नहीं, आपने हमको बताया तक नहीं। ऐसा रिमार्क उन्होंने ये किया। और इसके आगे आपने ऐसे कोई बाहर के लोग यदि आते हैं तो हमको कम से कम इन्फॉर्म करना चाहिए आपको, डायरेक्टर। दैट इज, आई एम completely sorry for that. And we carried out a very large number of such different programs, especially organizing Sanskrit literature, scientific literature, science available in Sanskrit. Like this, so many such programs were arranged at IISc Bangalore. Even now, I should not say, but it was the emergency period, and that is, I was there in 1974 to 76. That was completely emergency period, and that so many such activities were also carried out in my room. So, like this, the entire, now today I am 75 plus. So the whole life I remember, I'm completely doing either. Even today, I have taken one trial on different material. We developed so many 6 or 7 such materials. One of them is a solar material developed from our ancient text, which is practiced now in Gujarat. The patent was sold there. Second is this DRDO materials, iron glass and Vatahana Keloha, general purpose constructional material for aeroplanes. Now, typical thing, a density of 1.04 and having a hardness of more than diamond. Very, very hard and tough material. But at the same time, it is very, very light. That's why the DRDO people, they are interested in these two materials, the window glass material, IR glass, and the Vatahana Keloha. The third important material we develop is the by which it is a, what do you call it as, typical combination of castable phosphor bronze. Now, this is again a very different type of material having some special properties. It is having a very, very our best type of mechanical properties. I think you might be knowing phosphor bronze is a very hard and tough material used especially for your bronze statues. So this material is like that, but it is having at the same time very good. You can very easily give suitable shapes, machinability. So that is also very good. So this type of material, they are actually interested. Out of 6 materials we developed, they have picked up initially these two, IR glass and the Vatahana Keloha. We actually prepared the material in their lab at DRDO Hyderabad and they are satisfied. All the other property testing they are carrying out. Any more information, sir?
I think we are actually running. Yeah. No, I think this is sufficient, sir. And is many participants, they have expressed their thanks for sharing your experience. And one question is there. Let me check. Just a second. Rajni ma'am, you can unmute. Just a second. Just a minute. Ma'am, you can unmute yourself. Anyway, she has one suggestion. She said she taught Indian knowledge system previously in her college. So can you please give your thoughtful insights on teaching methodologies which has to be adopted while teaching such a subject?
Yes.
Uh,
The first experiment was carried out at VNIT in Nagpur. Of all the various regional engineering colleges, we carried out this experiment. We started uh, open electives for all the branches only for final years. And this elective I have started as Ancient Indian Technologies and Materials somewhere around 2007 or 8. And the response, because it is open elective for all the branches, including architecture. So the first time the registration strength was more than 500. So how to take such a large number in one single class? That was actually a problem. So we restricted the entries. Say we accommodated only 150 student per batch. Like this, the open elective was started somewhere around 2007. And regularly we are conducting in almost all the up to my retirement. I retired in 2015. So till that time, we the all other loads, teaching load, was completely removed from me. And only I was taking this open elective containing 150 students of different branches, final years only. And it is a very troublesome job because every um, branch is to be given suitable as per our uh, modules. You have to give one assignment and one final small project. So for this, the criteria was entirely different for different branches. For architecture, different types of Vastu Shastra and other things. For mechanical engineering, it was completely different thing. For metallurgy, it is again a different thing. For electrical electronics, we have a typical which was taught in my open elective, that is um, Shri Bhu Valaya Yantra. That is a typical thing containing a matrix of 27 by 27 uh, Kannada letters. Kannada, क्या बोलते हैं उसको? Yes, Kannada letters, and their how to decode that so that it is converted into a Sanskrit or Kannada shloka. That procedure was given. Nayana Bandha, Chakra Bandha, spiral type, Danda Bandha, vertical. Like this Karna Bandha. So like this 40 such different bandhas to decode that particular matrix. That was actually our Karnataka Shravan Belgola, you might be knowing, where the entire statue was there of 200 feet. And Jain Maharshi, that is, so that Dugdhabhishek Karyakram was actually carried out there. So he was actually the original Rishabh Dev, the first guru of Jain Tirthankar, and the whole knowledge available on the earth, Shri Bhu Valaya Yantra. It was only a simple matrix of 27 by 27 letters, and it will give you, by decoding by several ways, 40 text of 60 lakh shlokas in each, and it can be converted to 110 languages. So it is a whole huge. So if you transmit or it has transfer that matrix along with the decoding information from, say, India to America, it will hardly take few seconds, and the entire text of all these different languages, it contains Ramayana, Mahabharata, Bharat, Natya Muni, Natya Shastra, everything. So like this, you are transferring the entire knowledge from India to other country within few seconds, simply by transferring that matrix along with the required information to decode. So that is a typical thing which was given as a project for the electronics and computer engineers final year. And the whole atmosphere, I was taking the classes of 150 students near the canteen lawn, and the students were actually enjoying the entire thing. Like this, I continued for at least 6 to 7 years till my retirement. Professor Vijay Bhatkar, he was actually very much interested, and we were together since I was secretary of Vigyan Bharati, All India secretary, and we selected him as a president. So we were together meeting at Nagpur, Pune, or various places. Different. My guru, Dr. K.I. Vasu from IIC Bangalore, he was actually the founder president. After completing his 81st year, he was slightly having problems in traveling here and there. So, due to age, and he told me that somebody is actually required as a president, and we choose Dr. Vijay Bhatkar as a president. I was secretary again, and we developed, say, 50 lakhs, say, corpus fund for the Vigyan Bharati to carry out different activities at different places. Each state, each unit is having a particular aim and objective. So like this, 28 units were registered units of Vigyan Bharati was there somewhere around. I was actually the Secretary General, and traveling so much. One day, and for that, my many thanks to our VNIT director. He has shown very liberal attitude to carry out this particular work, one day, especially Friday, Saturday, and Sunday, I was not available in Nagpur, having some typical, say, we decoded Bhagavad Gita, we decoded Maitrayani Samhita, so many texts, and we were invited there in वो क्या उसका भगवत गीता का कुरुक्षेत्र में we were invited at Gita Jayanti. I think Gita Jayanti was few days back. So we were invited there and giving lectures on Bhagavad Gita, especially from the viewpoint of science and technology. We decoded the entire chapter there, and that was, to the surprise, the Sanskrit people, more than 100 in their traditional dresses, they were with us at that time. And whole, it was some conference of science and Sanskrit. So 100 scientists and more than 100 Sanskrit scholars, they were together in that particular conference at Kurukshetra, Ambala. Then from 2005 2006, so many such conferences were arranged at different units, and we are actually giving our proceedings of Vigyan Bharati there. So like this, I am having a very large experience, not only in the area of your science and technology, but also this area in which we were living, Shivaji Nagar. I was actually secretary of Shivaji Nagar Nagrik Mandal, and we conducted so many programs, and the corporation, Nagpur Municipal NMC, has donated 3 plots which are reserved for institutional or educational purposes. They were allotted to us for, which is around 18,000 square feet area. We constructed now a hall there, a basketball in the other ground, which was taking the help of one of my corporator, especially BJP corporator. The entire Trikoni, yes, was developed and is basketball ground in Shivaji Nagar. So also the maps of all these area, because it is very difficult to locate the plots. They are spirally arranged. So it is difficult. So for that, also different maps at 3 different corners were installed by me. Swimming pool of NMC was also given to me by corporation. I have conducted, educated more than 1,500 to 2,000 swimmers there. So like this, for the area, for Nagpur, for the Ram Janmabhoomi, I was actually again at that time, 92, I was there at Ayodhya. We collected more than 1 crore fund from Nagpur, this locality. So like this, the entire thing is going on. Because we are basically, my uncle was the Vivekananda Rock Memorial. He was full-time worker of RSS. And our home was not only a home, it was a like Karyalaya.
Social center.
Social center. Vishwa Hindu Parishad and BJP and so many things. RSS, Akhil
Sir,
Bharatiya Vidyarthi Parishad. Huh.
actually, we are running out of time now.
Right. बोलिए और कुछ
Uh, no, sir. Many participants they are expressing very, I mean, thankful message for giving wonderful information about ancient techniques related to metallurgy. Uh, on behalf of Maharishi Karve Sri Shikshan Sanstha and Cummins College, once again, I want to express my heartfelt thank to you for sparing time at such a age and giving the insights on your topic.
To your surprise, again, one thing, the first lecture or presentation on this IR glass was given at your Maharishi Karve Institute of Technology for Women
Yeah. Cummins
at
College
Pune,
and
Cummins
Pune.
College.
Cummins College
At
at Pune.
our one of our colleague Varnekar,
Yes, Varnekar sir was principal there.
he was a director there,
Yes, sir.
and in his hall, director chamber, the presentation was given. So many people from different areas, Pune, Bangalore, Mangalore, Nagpur, Indore, they were together, Varanasi, they were together to have this particular presentation on IR class.
Yes, sir. Okay, sir. Thank you. We conclude with this.
Yeah,
And with your permission, I just end this meeting.
right.
Yes, okay. So thank you. Thank you very much, sir.